Okay, so in this lesson, we're gonna discuss how to use these compound interest formulas. And so there are two formulas, and you don't have to memorize those formulas. I will give you those formulas on a test in the final exam. But here's the situation. So you have this formula right here, and you have this one, and they look totally different. You're going to use one. You're going to use this one whenever the information in the problem says something to the effect that interest is being compounded a finite number of times. And you're going to see what I mean by that. You're going to use this one, this formula here, when you in the problem you see or read part of that says that interest is being compounded continuously. So that word continuously tells you right away that you're going to use this formula here. Now, most students remember this formula as PERT, P-E-R-T. I do want you to be aware, though, that RT, R times T, see that's a product right here, that's the exponent of the number E. And remember, E is an irrational number. So in previous problems, we saw that E is approximately equal to 2.718. And so let's talk about this now for a moment. So, well, in both of them. So notice that in both of them you see the letter A. So A in both cases means future value, future future value, okay, or the amount you end up with, something like that. But think about it in terms of future value. You see P in both cases, so P is the principal, Principal, the principal, or you can also think of it as the amount invested, the amount invested. And remember when you talked about previous application problems, that P was the initial amount. So the amount invested, the initial amount invested. You see an R in both cases. So R is the interest rate, the interest rate. And whenever you use it, it must be written as a decimal. So you have to write it as a decimal. So you must change the percent to a decimal. You see a time in both cases, a T in both cases, that's time. And when you use time, time must be in years. So it has to be in years. All right, and then the only thing here that you see that's not here, and this is the part that that lets you know that you're dealing with this formula, compounded finite number of times. N tells you how many times the interest is being compounded per year. So if you're told that interest is being compounded, let's say annually, then that means N is one time a year. If you're told it's being compounded monthly, then you for 12 months in a year. For daily, you're going to use N to be 365. Okay. You could also be told that your interest is being compounded quarterly. So that means every 3 months. So N is 4. So N would be 4. And let's see, the only other thing I could think of that's more common is semi-annually. So semi-annually, so if annually is 1, semi-annually is 2. So N is 2. Okay? All right, so that's what you're going to see in these problems. So let's go ahead and look at number 1. So we do number 1. Now you need to make sure that you know how to use your calculator. That is very important. So if you don't have the instructions, you need to Google whatever calculator you have to see how to input things into your calculator. All right, so it says this: use the compound interest formula to determine the final value. And remember, final value means the same thing as future value. All right, future value. And future value, remember, that's at A. That's A. So that's A in both cases. So you're trying to find A in both cases. All right, um, so find the future value of the given amount, and then we're just going to round to the nearest cent in the end. And when we talk about the nearest cent, it's very important that you know the place value of the nearest cent. That's important. Make sure you know what we mean by nearest cent. Okay, so you have $700 at 6% compounded annually for 8 years. So remember your formula. So I'm going to go ahead and write down the formula. Remember, there are two formulas. So you need to determine which one you're going to use. Do I use this one or do I use the PERT one? This one. So notice that it doesn't say anything about being compounded continuously. In fact, you know it's different because you're given an idea about n. So it's being compounded annually. That's n right there. N is 1. Okay? So n is 1. So this part here says that n is 1. 8 is your years. I mean, is your time. So t is time here, right? This is your rate. So that's r. And 700 is your principal. So that's the information you need. And so again, you're going to use this formula. So you can use this formula. Go ahead and write it out here. So for this one, you're going to use A equals P times 1 plus R divided by N raised to the NT. All right, so let's go ahead and substitute. So you're trying to find the future value. So you're trying to find A. So that's the easy kind. The easy kind is where you're trying to find A, and you just use your calculator. So A equals P, the principal, which is 700, times 1 plus, see 1 plus, R. Now don't put 6, you got to, remember it's 6%, you got to write as a decimal. So 6% as a decimal is 0.06. Divided by N, N is the number of times being compounded a year, so annually means 1, so N is 1. Raised to the, now here's the way I would do this. Okay, I would always, because it's going to matter how you put this in your calculator for the exponent. I would always put NT in parentheses, no matter how easy it is for you to determine it right away. So if this is 2 times 3, you know it's 6, but still put in parentheses, so that way you get into the habit of doing that. Okay, so I'm going to put that in parentheses. So N times T, right? So N is 1 times T, which is 8. Okay, so that's what you have. And then all you do is take what you see and put into your calculator. So watch how simple this is. Okay, so watch. All right, so 700 times parentheses 1 plus. Now, all of you know that 0.06 divided by 1 is 0.06. So if you just want to say plus 0.06 and then close your parentheses, you can. Many students, just to feel safe, they'll just say 0.06 divided by 1. No big deal. That doesn't bother me. Parentheses, but now you got to raise it to, you have to raise this now, this right here, to that exponent. Now that exponent is a product, so you got to put open parentheses. Oops, I'm sorry. I cleared it. Let me do it again. All right, so let's do it again. 700, open parentheses, 1 plus 0.06 divided by 1, close the parentheses. Now I've got to raise it to an exponent. So remember, you got to use this right here, this button here, that button that looks like a roof. See how now it shows up? Okay, now you can put that in parentheses. 1 times 8, close the parentheses, make sure you close it, and then press equal. Okay, and so it said nearest cent. Now let me explain to you what I mean by the nearest cent. I'm going to go ahead and write out what I see on this calculator. I'm not going to do all the digits, but this is what I see on the calculator. On my calculator, I see this. Okay? All right, so that's what you see in your calculator. So let me explain to you what nearest cent means. So when you talk about money, so when you go and buy something at a store, and they'll say something like $3.42, right? $8.25. So notice that the last digit is in the hundredths place. So that is the nearest cent right here. The hundredths place is the nearest cent. HUNDREDTHS. The hundredths place is the nearest cent. But remember, when rounding off, you have to look at the digit to the right. So if that is 5 or larger, then you add 1 to this digit. Well, since it's not, the 9 stays 9. So this is what you would write. So the answer you're going to write will be $1,115.69. Okay? All right, number 2. So number 2, again, you're going to determine the formula. So this formula is the same as this one because it doesn't use the word continuous. This is the only one where you see continuous. So you're going to use that same formula. So you're going to say A equals P. Remember, this is P here. So 1,250 times 1 plus R, and the rate's 4.3%. So you move your decimal point 2 places to the left. So 0.043 divided by n. So this says daily, so remember there are 365 days in a year. Close the parentheses. And now you're going to raise it in parentheses. Your exponent is n times t. So you're going to say n, which is daily, so that's 365, times t, which is 12. So your time is 12. Okay? All right, now, so let's use your calculator. Okay, so what's happening now? Okay, so I'm trying to get the glare out the calculator. All right, so 1250, okay? Open parentheses, 1 plus 0.043 divided by 365, close the parentheses, raise 2, and then open parentheses, 365 times 12, close the parentheses, and then press equal. And so that's what you have. Now remember the nearest cent. So notice that this first 7 that you see is in the hundreds place, but you got to look at the thousands place now. So since 7 is greater than or equal to 5, this 7 becomes 8. So the answer is going to be 2094.08. Okay. Now I want to show you something. See, if you had not used parentheses here, if you forgot to put that in parentheses, this exponent, I want to show you what's going to happen. Remember, that's the answer, right? I want to show you what's going to happen. So if you don't put that in parentheses, here's what you would say. You would say 12,050, open parentheses, 1 plus 0.043, divided by 365, close parentheses, raise 2, and then let's suppose you forgot about the parentheses. So you're going to say 365 times 12, okay? You see no parentheses, right? Okay. So when I do that, I'm going to press equal, and notice you get a different answer. What happened is this. Let me go back to it. What happened is this. I'm going to tell you what you're doing. So you see right here when I raise this right here, so that's this part here, to the 365th power, and then set times, what's happening is that the only thing that's being raised to the 365th power is this right here. So notice you're saying this to 365, and whatever that is, whatever that whole thing is, you're multiplying by 12. But that's not what that 12 says. That 12 says that this is also being raised to the 12th power, not multiplied. And so that's what you're doing when you forget to put parentheses. When you forget to put parentheses right here, then you're raising this only to the nth power and not raising it to the t. What you're doing is multiplying by t, and that's not what that says. So that's why some students, quite a few students, will always put that in parentheses just to make sure they don't mess up. All right, letter C. So now we're talking about continuously. So that's this formula here. A equals P times e to the RT. So you're trying to find the future value. Now let me just remind you what you have here. So that means that in 8 years you went from $700 to $1,115.69. Now that's assuming you don't take out anything, right? You're leaving $700 in. You're not touching it. You're not adding to it. You're just letting the interest accumulate. So your interest is earning interest, and so that's what you end up with. So over here, $1,250. If you don't add anything to that amount, if you don't take out, if you just leave it in for 12 years, that's not really what happens in real life, right? But if you leave that in 12 years, then that $1,250 will become a little over $2,000. Okay? So what happened is that extra money is interest. So your interest was earning interest as well. Okay? All right. So letter C, you have A equals, the principal is 1,400 times 1 plus, I'm sorry, excuse me. Okay, so let's do it again. So A equals P times E. Okay, A equals P, 1,400, times E raised to the, I put that in parentheses, the rate is 7.5 percent, you got to change that to a decimal, so that's 0.075. Now, when I say change to a decimal, I mean drop the percent and move the decimal point. That's what we mean. Times, so I'm going to put a larger dot for multiplication. So that decimal is being multiplied by t, which is 7. Close the parentheses. And then use your calculator. So in the previous lesson, you were given examples of evaluating e to a power. So let's see. So you're going to say, make sure you remember how to do that. So you're going to say 1400. So 1400 times e. Now remember to get the e. So that's, you can't see it very well, but that's right above the ln button. See, it's blue right here. So remember we did second ln. So when I do that, watch, second ln, I get that e. Now it automatically puts parentheses for you. So you're going to say 0.075 times 7, and then don't forget to close the parentheses. See right here? And you get this amount. Okay? So to the nearest cent, see the 4 is in the hundredths place. So you got to look at the thousands. Since that is less than 5, the 4 stays 4. So at the end of 7 years, if I don't add anything to this amount or take anything out, this 1,400 will become $2,366.64. All right. Letter D. Okay, this time you're talking about this monthly now. So that's that other formula. So you're going to say A equals P, which is 1,800, times 1 plus the rate. So remember, you got to change the percent to a decimal. So when you move it 2 places to the left, that becomes 0.108. 0.108 divided by n. Remember, n is the number of times being compounded per year, so that's monthly, so that's 12. Raised to parentheses, nt. So n, this 12 becomes this 12 right here. N times t, and t is 3.5. Okay, and remember, t must be in years, so notice in every case the time was in years. And then all you do is use your calculator to determine that. So let's see what we get. So 1,800, parentheses, 1 plus 0.108 divided by 12, close the parentheses. Now I've got to raise it to this exponent. So you're going to use this button here. So notice this shows up. Don't forget to your parentheses, because if you don't, then you're only raising it to the 12th power, and you're also supposed to be raising it to the third as well. So you're going to say parentheses, 12 times 3, close the parentheses, press equal, and you get that. All right, so you're going to get, let's see now, remember to the nearest cent, so 6 is in the hundredths place. So you look at the thousands, since that's less than 5, 6 stays 6. So 2485.16. Now some of you may ask, if you know what 12 times 3.5 is. So let's say real quickly you do this, 12 times 3.5. Could you just say 42 instead of saying all this? Yes, you can. You definitely can. So here's what you could do. So if this is easy to compute, then do it. Okay, it's up to you. Many students don't do that. They just write what they see in the calculator. So you know this is 42. We just saw that. So you're going to say 1,800. What happens? 1,800 parentheses 1 plus 0.108 divided by 12. Close the parentheses, raise 2, and then notice you're just putting 42, right? 42, no parentheses at all, because it's just one number. Equal, and you get the same thing. Okay? Oops, no, you don't. Okay, so make sure, so you see how I got something different? So that means I did a typo somewhere. So let me just check it again, okay? So let me go back. We saw that this was 42. So maybe I did an error somewhere. So let me go back and move this arrow up and see what happens. So 1,800 is correct. So that's correct. 1 plus 0.108, that's correct. Divided by 12, that's correct. Raised to the 42nd power. All right, so that's correct. So maybe I made an error here. So let's check that. So 1,800. So let's do it again. 1,800 times 1 plus 0.108 divided by 12, close the parentheses, raise 2, and then 12 times 3.5, close the parentheses, press equal. Yeah, so I made an error here. So I'm not sure what happened to my calculator at the beginning. But yeah, so when I did it using the calculator using the parentheses, this was not correct. So I'm not sure what happened. So it's going to happen sometime. So that's why when it says show work, when it says show work and you don't, and all you have is an answer, and it's incorrect. But if you show the work and all of this is correct, you'll get quite a few points. So that's why it's important you show your work, and this will be the work there. Okay, so be careful. So now notice the nearest cent, one's is in the hundreds place. So now since this is 5 and it's 5 or bigger, then 1 becomes 2. So the answer is 2622.42. All right, and so notice the only reason I caught that was because I went back and I changed this to 42. So I'm hoping that I didn't make an error on these. Now this part's correct, but I could have, when I put in the calculator, just very easily have put in the wrong digit. It's very easy to put in a wrong digit in your calculator. So sometimes you may want to double check your answers. Okay, letter E. Okay, this I'm being compounded quarterly. Remember, quarterly means n is 4. All right, so I get A equals the principal, which is 3,000, times 1 plus R, which is 4%. So as a decimal, that's 0.04, divided by 4, raised to, parentheses, raised to, 4 times T, and T is 8.5. All right, so let's use a calculator. So let's see, we get 3,000, open parentheses, 1 plus 0.04 divided by 4, close the parentheses, right? Raised to, open parentheses, 4 times 8.5, close the parentheses, and then press equal. And so to the nearest cent, so 3's in the hundreds place, this and you don't have to change 3. 3 stays 3 because that's a 0. So you get 4207.73. So at the end of 8.5 years, this $3,000 has grown to that amount. So it's a long time to get an extra $1,000. 8.5 years to get an extra $1,000. But that's what you have here. All right. Okay. So that is number 1. So that's number 1. Okay. Let's look at number 2. So in number 2, we have this in number 2. Okay, so number 2, we have, suppose that you deposit $5,000 into a certificate deposit. Determine the future value of the deposit if it earns 7% interest compounded continuously. So notice it's continuous, so we're going to use continuous compounding for each of those. So we already know what the formula we're going to use. We're going to use this formula, A equals P times E to the RT. All right, so here we go. So for 2 years, that's your time. Time is 2. So A equals the principal, which is $5,000. That's your initial amount, times E, and let's go ahead and put parentheses here, raised to the RT. So R is 7%, so that's 0.07, times, I'll put a darker dot here for multiplication, so don't confuse with the decimal point, times the time, and the time is 2. And then all you do is use your calculator. So in your calculator, you're going to say 5,000. Now you got to get that E function. So to get that E, remember it's right above is that LN button. So you got to press second LN, and notice that shows up. 0.07 times 2, close the parentheses, and then press equal, and there you go. So to the nearest cent, so that's a hundredths place. So this 6 has become 7. So we get $5,751.37. Okay. 3. So this time we have A equals 5,000 times E. And now notice everything's staying the same, right? The only thing that's going to change, I want you to notice, the only thing that's changing is your time, correct? The principal stayed the same. Everything stays the same. The only thing that's different is the time, the years. So times 3. So the same process. Let's see what we get this time. Now I want you to notice, if you don't take anything out, I'm hoping you realize that the future value is going to increase each time, right? Okay. So 5,000, second ln, so you get that. Right here, you get that E function. and then my exponent will be 0.07 times 3, close the parentheses, press equal, and you get this. So that's going to be $6,168.39. Okay, the next one. So A equals 5,000 times E raised to the 0.07 times 6. All right, so let's see what we get. So 5,000, second ln, see that E button, and then 0.07 times 6, close the parentheses, press equal. So you get that amount. So you get $7,609.81. Make sure you're rounding to the place it told you to, so the nearest cent. Now, it didn't say anything about rounding here, but since it did not, I'm just going to use the nearest cent, because and the reason I'm doing that is just to keep reminding you the nearest cent is a hundredths place. The nearest cent is the hundredths place. Okay, that was number 2. Okay, let's see number 3. All right, number 3. Number 3, we have this for number 3. And let me make sure I didn't skip a page. Okay, so I think we're good so far. All right, so this is number 3. So number 3, it says find A, the future value of the given principal, and so here's your principal, and the interest earned in the given period. So let's do the A part first. So the A, you want to find the future value. So that, and notice it's being compounded quarterly. So not continuously, quarterly. So n is 4 here. That's what that means. So A equals 3,800 times 1 plus, and then the rate, 4.5%. When you change the percent to a decimal, you get 0.045 divided by n is 4, raised to, in parentheses, n time, 4 times t, and t is 16, right? Okay, and so use your calculator to round that to the nearest dollar this time. So let's talk about what we mean by dollar. Okay, so let's see what this is. So I get 3,800 times parentheses 1 plus 0.045 divided by 4, close the parentheses, raised to open parentheses, and then 4 times 16. 4 times 16, close the parentheses, and then press equal. Okay? All right, so you get this. Now, make sure you always use the directions in terms of rounding. It says the nearest dollar. So I want you to notice the nearest dollar right here means the nearest whole number. Nearest whole number. And so when you talk about the nearest whole number, you don't want any digits behind the decimal point. So when you talk about rounding to the nearest whole number, you're rounding to the ones place. The ones place. So notice that this first 5 that you see right here, that's the ones place. 7's in the tens place. This 7's in the hundreds place. And this is in the thousands place. So whenever you round to the nearest whole number, you're rounding to the ones place. So whenever the digit that you're rounding off at, you got to look at the digit to the right. Well, and that's going to be the tenths place. So since this is 5, this 5 becomes 6. So you're going to get $7,776. Okay? All right. Now, so that was part A. Part B, though, said this now. Part B says find the interest earned in the given period. Well, remember, you went from $3,800 to $7,776. You didn't put any extra money in at all. None whatsoever. So that money you earned is nothing but interest. That's what you earned. The only amount you put in was this. Everything else is interest. And so they're asking you to find the interest. Well, to find the interest, you're going to subtract what you put in from what you earned. So 7,776 subtract 3,800 equals, and let's see what that is. So 7,776 subtract 3,800 equals, and that's your interest. That's how much interest you've earned. Now, it took you a long time, 16 years, right? That's a heck of a time to just earn $4,000. So that becomes 3,976 is your interest. That's the interest earned during that time period. Okay? All right, number 4. Number 4 says find the principal. Okay, so let's talk about what this means now. So in every other problem, you are asked to find the future value. Go back, you'll see future value, final value, the amount in the account after so many years. Okay, you're asked to find A. This time though, um, you're asked to find the principal. It's not difficult. It's very easy to do. You just got to know how to solve a linear equation, and which all of you do. All right, so here's what you do. Now notice that this is compounded monthly, so you can use this formula. So I'm going to write out the formula you're going to use. A equals P times 1 plus R divided by N raised to the NT. That's the formula you're going to use because it says compounded monthly. So that means N is 12. Okay, so let's plug in what we know. We don't know A. That's what I'm sorry. We do know A. A is $9,000. So you're told you want to end up with $9,000. So at the end of 10 years, this is what you want. And in 10 years, this is what you want to end up with. So that's your future value right there. A, $9,000. So $9,000 equals the principal. So you want to know, what should I invest now so that way in 10 years I'll have $9,000. All right, so that's what you're trying to find. 1 plus R, which is 0.08, divided by N, which is 12, raised to, in parentheses, N, which is 12, times 10. Okay? And then what I would do is this. Now notice that see your variables here, right? So what I would do is I would figure out what this is right here. See this little part? Figure out what that is, and you're gonna see what's gonna happen in a little while. So it's gonna make sense to you what's happening. So if I multiply this, so this part here, you're saying this, parentheses 1 plus 0.08 divided by 12, close the parentheses, but you got to raise it to this power. So you can say 120, or you can say 12 times 10. But if you say 12 times 10, you got to put that in parentheses. So I'm going to raise it to the, I'm going to put parentheses since that's what we've been doing. 12 times 10, close the parentheses, and you get this. Okay, now, it did say you want to round the final answer to the nearest cent. So let's just use the cent here. So to the nearest cent, this right here, that right there is 2.22. Okay, so I get 9,000 equals 2.22p. So this is 2.22, right? That's what this is. So 2.22 times p. Now to get p by itself, right now multiplying by 2.22, so you're going to divide by 2.22, just like this. And so therefore p, the amount that you have to initially invest, so your principal will have to be, and you just say 9,000 divided by that. So 9,000 divided by 2.22, so you're going to have to initially invest about $4,054. And it did say the nearest cent, so let's do $4,054.05. So $4,054.05. So that's the amount you will initially have to invest. So you got to invest now, the amount to invest now. So that way in 10 years, you're going to end up with $9,000. Okay? Now remember, we did round this off, right? So this is not an exact answer. We're approximating this because we did not use all the digits. We approximated. Okay, let's look at number 5. So same thing, number 5, you want to find the principal that will generate the given future value of $12,500. Compounded quarterly for 8 years at this interest rate. And then this time we're going to round to the nearest whole dollar. Now, we need to be careful when we do this. We need to be careful because that's a decimal, and sometimes those decimals can be very small. See, like 2.22? That's a very small number. So when we do this one, we may, even though it says round to nearest whole dollar, the final answer has to be round to nearest whole dollar. But when we write this right here, I'm going to put quite a few digits. Just the more digits you have, the more digits you have in the denominator, the better your approximation is for your answer. Okay, so let's go ahead and do this. So n is going to be 4 in this case, right? So I get 12,500. That's your future value. Will equal the principal times 1 plus the rate, which is 0.075 divided by 4 raised to the 4 times, and then the time is 8. So that's going to be approximately equal to, use your calculator. So in your calculator, you're going to get, let's see, you're going to get, remember, this is what you're doing. You're figuring this part out right here. And I need to be careful with this. I shouldn't have put that yes just yet. So you're going to get parentheses, 1 plus 0.075 divided by 4, close the parentheses, raised to the open parentheses, 4 times 8, close the parentheses, and you get this. Now, so don't even though it says round the nearest whole dollar, it's your final answer that you want to the nearest whole dollar. Well, I would actually put in maybe about 4 digits behind the decimal point. So I'm going to round this piece off right here as 1.8120, or let's say, and if you want to, you can put all these if you want to. Now remember that's not a terminating decimal. I hope you see that because you have a lot more. You have an infinite number of digits to the end here. Okay, so I'm going to say this: 12,500 equals, and then I'm going to rewrite this part as 1.81202. 1.81202 times p. The more digits you have, the better your approximation for p. The more digits you have here, the better your approximation for t. So if you had just used 2, then that would not be a very good approximation. All right, so then to get p by itself, let me go ahead and rewrite this. To get p by itself, right now I'm multiplying by this coefficient, so I'm going to divide by it. Okay, just like this. Okay, and then I'm going to reduce, so I get p is approximately equal to, so the amount I've got to invest now will be, so let's divide this out. So you're going to say 12,500 divided by 1.18202 equals, and then to the nearest whole dollar, so the nearest whole number, since the tens place is 1, is going to stay 5. So $10,575. So if I in 8 years, if I want to end up with $12,500, then I need to invest about $10,575. That's what I would need to invest. Okay, so remember that's what that means. So remember that means that I need to invest. I need to invest $10,575 now, so that in 10 years, I'm sorry, 8 years, 8 years, I will have $12,500. That's what you just found. Now, I want to go back and tell you, remember we said the more digits you use here, the better your approximation. So if I use a lot more, then this would become much better. So if you just put, let's say, that should be, maybe, I think I made a mistake here. I got to go back and redo this. So 1.81202, see right here, I kind of switched this around. I messed up, so let me go back and fix this. Go back and fix this. So let's do this again. So 12,500 divided by 1.81202. And you get this. Oops. Do it again. 12,500 divided by 1.81202, right? Okay, make sure that's correct. Yep, okay. Then press equal. All right, so that's incorrect right here. So that should be, okay, the tens place is 3, so that's going to stay 8. So that's going to be $6,898. So you need to invest that amount now, $6,898, so that in 8 years you'll have this amount. Okay. Now I want to tell you, if you had used, see how when we did when we figured out what this value is, we got this, and some of you may have said, well, can I just use 1.8? Well, so let's talk about that. If you use 1.8, so if instead of using all these digits, you use 1.8, let's see how much this changes by. So 12,500 divided by 1.8, and you get this, $6,944. So it changes. It doesn't look like it changed that much, but really, you don't have to invest that much to get $12,500. It's supposed to be less than that, which it is. Okay, so don't use, for when this part here, I would use maybe 5 digits. So try and put 5 digits behind the decimal point just to get this to be a very good approximation. All right, and I didn't do that here. So if I go back and I do that here, let's see what happens. Let's just do it. So let's go back and look at this again. So 1 plus 0.08 divided by 12, close the parentheses, and remember it's being raised to the 120th power, so 120, and I get this. So remember that? So I want to show you, if you instead, just to show you, if you instead, try to get another sheet of paper, if you instead used, let's say, 5 digits, so 9,000 divided by 9,000 divided, instead of using this, we use 2.21964, 2.21964, so 5 digits behind the decimal point. Let's see how much difference that is. So 9,000 divided by 2.21964 equals 4,055, right? And then what we ended up with was 4,054. It's not that bad, just $1 off. Okay, so but technically, the more digits you have, the better your approximation. So even though we used just the hundreds place here instead of all of these, that approximation wasn't way off. Okay, so guys, I think that is the end of our lesson on compound interest.